Right, so my name is Ted de Boer. Some of you will already know me as I used to be a product manager at Mero Distribution as well. I've since moved on to Siae Microelectronica, and today I want to thank Mero for having me here first and foremost. I'll be doing a bit of a sort of a dive into a guide to a reliable carrier class network. As the agenda, I'll be discussing growth as a whole for a network in particular. Then I'll go through some challenges. Then I'll discuss the key components of Carrier Backhaul from a Siae point of view within Mero. Then I'll quickly go over the basics of what is right for you in terms of capacity, distance, and lead times and so forth. And then I'll try and work in within the time given what we can offer as Siae. So since I've been working for Siae, I've come to learn that there's much more than just Alpha Plus 17. Some of those products we'll be introducing into the Mero portfolio very, very soon, so keep an eye out for that. And at the last slide, my details will be there, so you can always email me personally if you have any questions, and otherwise you can contact me via the guys at Mero here as well. I don't know if there's time for a short Q&A, but we'll see. All right, let's get started. So with regards to growth in a network, reliability is of the utmost importance when it comes to growth, not only because reliability promotes growth, but it also sustains that growth. And in order to have a reliable network, you need carrier class hardware at a certain point in time. So obviously when you start out, things like even power beams in MikroTik net metals are more than sufficient for the level of and quantity of customers that you're carrying. But as that increases, you need to move to some hardware that might be a little bit more or much more reliable. And then secondly, with growth, you need to look at predictability of your network performance. So when you're playing in 2.4 gigahertz, 5.8, and even in some cases 17, you need to worry about what will happen when a lot of other guys start using that spectrum. And predictability comes in at carrier class RF performance and predictability of the RF performance, right? So the grade has two tiers. On the one side, it's the hardware that is proven to be extremely reliable, and on the other side, it's licensed spectrum that is yours to use and only yours to use, which means there's no interference. And secondly, that means that you can do planning and allocate for the amount of uptime that you really need. It's not a guesstimate, it's a given, because it's based on a whole number of factors. One of them, for example, being rain attenuation. So yeah, carrier class RF performance, predictability through that RF performance, and then of course scalability. So future growth requirements of the network capacity that you need to keep in mind. You don't necessarily have to spend a whole lot of money right off the bat. You can cater for what you need right now, and then those links you can either upgrade or you can move them outside of your network into new areas where the specific capacity there might not be so necessary. So you have a 400 meg Siae 17 gig link, you replace it with something E-band, and then you move 17 gig out into the rural areas, that type of stuff. Right, then the challenges of using legacy networking equipment. With legacy, I mean kit that might have aged a little bit or is not up to par anymore for the network that you're running or trying to run. Of course, there's the issue of interference, as always, well-known fact. Then there's the lack of capacity, so a couple of 100 megs might not cut it anymore in these days. And then, of course, also having too many hops in your network, rather maybe have a license link that's able to go a little bit further and carry much more capacity, rather than having a whole lot of smaller links that are TDD type of links and add to latency within your network. Then, of course, the challenge of covering certain distances as well, again, the reliability and stability. And then, secondly, the challenges of switching to that carrier networking equipment when it comes to WISPs such as yourselves. You know, when you want to purchase something from Miro, there's obviously there needs to be training involved, because typically on the carrier side of things, there's not a whole lot of content available on the web in terms of, you know, how to set this up. Not as like with Ubiquiti or Mikrotik. There's a whole lot of stuff to find on YouTube. With the carrier side of things, that's not always the case. There's planning involved, which sometimes takes some time. Type approvals, ICASA spectrum license applications, and then of course, especially with license kit, there's the lead time on equipment delivery. So how we will be addressing this going forward, in terms of training, there's of course Miro Academy online, as well as I'm assuming in the future there will be more class-based training as well, again. And of course, with regards to the new equipment that we'll be introducing, that we'll talk about a little bit just now, there will be training available on that as well. With regards to planning, you can always contact Miro technical support on support@miro.co.za. There you can log your details, your tower heights, your coordinates, and they will gladly be of assistance. This typically comes through to us. And we'll then do the planning for Miro and send it back to you guys. With regards to type approvals, most of the equipment that I'll be discussing today is already type approved. If there's a particular frequency on a particular product that you might want, then we can always look into type approving that, especially if there's a good run rate or, you know, sort of a growth of the network involved. Then with regards to ICASA spectrum license applications, Miro can assist with filling out this application. We also know a couple of guys within ICASA that we can use to check whether or not spectrum is available in your area at a certain frequency, which might speed up the process a little bit. Then with regards to lead time on equipment delivery, certain stock will, going forward, be held on hand in terms of license kit. But ideally, one would want to look at sort of 3 to 6 month planning cycles from your side. So if you know you want to, you know, in summertime, I want to put a link up in December when it's quiet, if not whatnot. Maybe start now to, you know, allocate some cash into an account for this specific link. Make sure you get the planning done now, and make sure you put in the application now and know what subband you're going to be on in order to order the kit on time. So if it's something in particular or very special that's not held on hand, then at least you have some lead time to wait for the stock, and by the time you want to install it, it's there and ready to go. Right, so key components of carrier backhaul from a Siae point of view. With regards to license exempt, we have the very well-known Siae Alpha Plus 17 gigahertz. With regards to fully licensed, there is the other frequencies within Alpha Plus. There's the dual core Alpha Plus 2, and of course the AGS 20 split mount solution. All of those run between 6 and 42 gigahertz. Then there's the Siae Alpha Plus 80 HDX E-band for 1780 gigahertz. And of course on light licensed, both light licensed and fully licensed on E-band is the Alpha Plus 80 HDX. Right, so what is right for you? So I tried to simplify it as much as possible. A few quick questions that you can ask yourself with regards to what you really need versus what you want, and versus what is, you know, necessary. First off, maybe ask yourself, what sort of distance am I looking at with regards to this backhaul or upgrade or link that I'm planning? If you have a look at the left bottom corner, if it's less than 4 kilometers, myself personally, I would always advise to go E-band. Reason why: licensing is cheap, capacity is immense, and typically an E-band radio will cover the entire E-band, so there's no particular subbands involved or anything like that effect. If it's longer than 4 kilometers, you can pick either 17 gigahertz license exempt, or license kit, or multiband. I'll chat a little bit about multiband just now, but yeah, in case you pick 17 gigahertz, but 400 megs is not enough, if you look at the middle bubble over there, then you would have to look at E-band if it's less than 4Ks, or licensed, or multiband. And then last, ideally, when looking at time, if it's immediate, 17 gigahertz is a very, very good temporary solution as well, or E-band, again, if you're within a certain range. But if you have time to plan and you have got some funds available, I would definitely recommend looking at a licensed solution, just because you have that peace of mind. It's your frequency, it's your equipment, and you know that you're going to have a 99.999% uptime available to you. And you know, the kit is good, the RF performance will be good because it's guaranteed, because you plan for it, you're paying for it, which means that you put the link in and you have peace of mind for the coming 5 odd years or more even. Right, so what's on offer from Siae? I'll quickly go through the entire portfolio at a glance, and then I'll just spit out some minor details on each and every single device within the portfolio. If you have any questions on any of those in particular, please feel free to pop me a mail afterwards. I'll gladly send you some brochures, manuals, whatever it is that you need, because I'm definitely not stingy with information. But yeah, let's go through it quickly. If you'll have a look on the left-hand side, the first AGS20 you can forget about, because it's a different solution as to what we're proposing to mirror. But secondly, the AGS20 M and L as well. Those are split mount solutions. They are paired with the AS&K radios you see next to it, and those AS&K radios also have high power and ultra high power variations thereof. And then for full outdoor, you'll see the Alpha Plus 2 and Alpha Plus 80 HDX. Reason why the Alpha Plus is not here is because it has a different operating system built into it. All of these that you're seeing here are running, at the bottom you can see SMOS, which is the latest Siae operating system. They're all unified, so they all run the same type of operating system, which means that if you're trained on the one, you can use every single one of them. If need be, there's a unified network management system as well that does run the other Alpha Pluses as well. All of this kit is 5G certified as well, should that be of interest to you running a mobile network operator. So first off, we have Alpha Plus. Very well known, so most of you have used this before will recognize the picture. This is in fact managed by NMS5, so different type of internal software, but it can be managed by the unified management system. It can do multiple services with the AGS20 combined, anywhere from 6 to 42 gigahertz, apart from 7, and then of course maximum of 1024 QAM, with adaptive coding and modulation. There's header compression that you can purchase with, and of course there's an extended warranty that you can purchase from Mirror as well, up to 36 months. Secondly, we have the Alpha Plus 2, so this will be a little bit more in depth because it's quite feature rich, this radio. So this is Siae's dual core radio, meaning there's 2 radios inside that can work together in XPIC formation, which is also built into the device itself. So it's all one unit, goes outdoor, attaches to either one dish or multiple dishes via waveguide. So there's a lot of configuration options that you can do with this. Up to 2 gigabits full duplex. That's if you're running at 112 megahertz channels in XPIC, then you can get up to that capacity. 4096 QAM, again with ACM. 212 megahertz channels for ETSI. In the US, it's 80 megahertz. XPIC header compression, and it can aggregate on layer 1 with E-band, our E-band product, which is called the multiband together. I'll touch on that quickly if I do get to it. With regards to this particular radio, we have different types of branching that are built into the device itself. So you can, if you have a look at the first one, it's a circular branch. It basically takes both of the radios together onto one dish, 2+0 XPIC. You can have them in a dual flange neutral mode, which means you have waveguide, and you attach them to an external antenna. And then there's the integrated hybrid. So if you have a look, it's one pole, but it will be multiple radios on one plane. So you can have them next to each other, adjacent, 2 channels, or you can space them out as well, which is pretty nifty. If you look at the device itself, in particular, close up from the bottom, there's a 10 gigabit SFP port, 2.5 gigabit. It can be powered by PoE or 48 volt DC. And it can be connected directly layer 1 aggregational speed with our E-band radio as well. Right, then the AGS20 family, I won't stop on this for too long because we're not planning as yet to introduce this via Miro, because it's pretty on the sort of mobile network operating side of things rather. But if there's interest in split mount, please by all means let us know. There's always a plan to be made. Right, so on the AGS20, this is the basic version, up to 4 intermediate frequency ports, those little golden connectors that you see there. This you can basically run 4 radios at the same time, or you can run in 4 directions with single radios, or you can have a quad core radio like the one in the middle at the bottom there, or a number of different configurations to suit your needs in all the frequencies from 6 to 42 gigahertz. This can also run on layer 1 hybrid lag with the E-band. So if you have an E-band that needs to go 10 kilometers and you need that uptime, you can pair it with this and it can run together and take care of downtime when there is rain involved. Right, then there's the M version, which is a modular version. It has also more switching capacity. It's compatible again with all of the same outdoor ODUs. This is split mount, so you will have IF cable going up to the site rather than RF cable, so there's no loss involved, but the radios are spoken to via a modem that's indoor, like you see over here. Again, this has an enormous ton of features available to it, runs on SMOS, it's manageable by NMS5, so lots of options there. And then last but not least, here we have a bit of a layout so you can see up close what it is. So there's a power supply unit on the left, there's your IF cables. It can also still handle E1s if that's something that you're still running on your network. A couple of Ethernet ports, and then there's of course your local management, sync and alarms on the right hand side. And last but not least, so this is the one I was speaking about, this is our aggregation unit. So this device has full redundancy in terms of power supplies, as well as ports and radio options, up to 8 IF ports, meaning up to 8 radios or 8 cores running all together, which means you can basically have either a very high capacity license link, or you can go into multiple directions, or you can have some safety and redundancy in place with protected 1+1 hot standby links. Just to go over the ODUs quickly, so this is the ASNK that works with the split mount system. It's very small, less than 1.7 liters, less than 2 kilograms, and only power consumption of 10 watts. But it can still do 4096 QAM at 112 megahertz. So this can definitely pull a good gigabit at least on a single pole link. Then there will be an evolution of these products going to dual carrier as well as quad carrier, and then at the bottom you can see what sort of setups you can do. So alternate polar or copolar, you can have them next to each other, or you can run full XPIC as well, going up to 4 gigabits per second in 4+0 quad carrier using one of the indoor units. Then E-band, so this is our Alpha Plus 80 HDX, available between 1 and 10 gigabits per radio. It can be paired with another one of these in XPIC, up to 20 gigabits per second capacity, which is quite significant. And as I said earlier, this is all compatible with SMOS in NMS5. I'm stumbling over my own words here, but this can also be paired with the Alpha Plus 2 or the split mount solution, and this then creates multiband. Right, so multiband links basically means you have a license link combined with an E-band link giving you the high capacity of E-band, but over further distances. And then you have your license link, which will give you at least like 800 megs or a gigabit worth of capacity when there is, in fact, some rain falling at that specific period in time, which might be a couple of minutes, which might be a little bit longer. But yeah, these can run together in layer 1 aggregation, which is pretty nice. So you have both the capacities at the same time. If you'll have a look here on the left-hand side, there's a capacity 10 gig, and then at the bottom you'll see the availability becoming more and more to the right-hand side. But you'll still have your 860 megs, even if the distance is that far and the rain is that much. If you want, I can send some of these slides to you guys at a later stage. But this is just to give an overview. We don't have a ton of time, but this gives you an indication of why multiband is there. Right, so if you'll have a look here, 3 channels, 2 frequencies, 1 antenna. So everything runs together on one dish. At the top you'll see the Alpha Plus AT-HDX, which is our E-band radio, and then it's branched into one of the split mountain radios, so this can be an ACE and K on both sides, running dual pole, everything on one dish. And we have this available currently in 15, 18, and 23 gigahertz multiband dishes. And the other option would be to pair it with our Alpha Plus 2, which will be introduced to Miro fairly shortly. And again, this is a branching solution, so these two sit on one dish outside, giving you an amazing amount of capacity. Seeing that the Alpha Plus 2 can do 2 gig, you would be running about 12 gigs most of the time, and up to 2 gigs in very bad weather, depending on what you're running, of course. Just to give you an idea here of what that looks like, again, in the technical drawing and the availability. So it's 18 gigahertz, 23 gigahertz, and 15 gigahertz that's currently available in terms of the dishes. This will obviously be expanded somewhat in the near future. That is pretty much all from me. If you have a look here at the bottom, there's my email address at Siae, so it's ted.deboer@siamic.com. You can write that down, pop me an email later if you'd like. And then my work number is there on the right hand side if you need to reach me via Skype, WhatsApp, or whatever form of communication it is that you want to use. I would like to thank everybody for attending. Sorry it was so fast and rumbly, but there's little time available. I'd rather stop ahead of time than too late.